In this question, we're adding a pretty good amount of a strong acid to a buffer. The buffer is composed of ammonia and ammonium ion. Ammonia, we know, is going to be our base. The ammonium ion is our acid. Okay, we put ammonium chloride in solution. We know we generate ammonium ions in solution and chloride ions. So we have NH3 and NH4 as our weak conjugate acid-base pair. I'm going to start by calculating the initial pH of this buffer using Henderson-Hasselbalch. pH is equal to pKa plus log of our base to our acid. Now we want to calculate our pKa, but we're given our Kb of ammonia, so we need to calculate the pKa of NH4+. So the Ka, we know, is going to be the Kw divided by the Kb. So you get 5.56 times 10 to the minus 10 with 2 sig figs. So we have, this is the negative log plus log. Our base again is ammonia, and the concentration of our base is 3 molar. Concentration of our acid is 2 molar. So this comes out to be 9.2553, and the second term is 0.1761. So our initial pH comes out to be 9.4314. Now the question didn't ask for this to calculate the initial pH, but I wanted to be able to compare after we've added a bunch of acid to this buffer. Alright, so what's going to happen when we add acid to the buffer is that the ratio of the base to the acid will change. Now, so let's calculate what that new ratio is going to be. When we add a strong acid, it's going to react with our base. And it converts our base, NH3, to NH4+. So we're going to lose NH3, gain NH4+. So let's calculate how much of each. We start with a 1 liter volume of each. Moles of NH3 initially is going to equal volume times molarity. So we've got 3 moles per liter and 1 liter. So we have 3 moles of our NH3. Moles of the NH4+ initially. We start with a 2 molar solution. And again we have 1 liter. So now we have 2 moles of NH4+. Alright, so again the added H plus converts the NH3 to ammonia. So the moles of NH3 final is going to equal the initial amount minus the amount of our acid that we add. So we started with 3.0 moles, and we're going to lose 1.5 moles because the added acid is going to convert, and 1.5 moles of NH3 to NH4+. So we now know we have 1.5 moles of NH3 left, and the moles of NH4 plus that's resulting, as we started with 2 moles, and we're going to gain the same amount of moles of NH4 that we lost of an NH3. So this is 3.5 moles. Okay, we remember that we're in the same volume for both the acid and the base, so we can take the shortcut that the concentration of the base to the acid is going to be the same as the moles of the base to the acid. So when we apply Henderson-Hasselbalch, pH is pKa plus log ratio of our base to our acid. Our pKa, again, is the pKa of our acid, NH4+. This is a negative log of 5.56 times 10 to the minus 10. And our base is the ammonia. So we have 1.5 to 3.5. Okay, we churn out this math, and this is 9.255, and we're adding a negative 0.368. So our new pH has gone down a bit, 8.887, 2 sig figs. It's gone down a bit, which is to be expected because we've added acid. It's going to become more acidic, but it really hasn't changed all that much. We've gone from 9.43 down to 8.89, so not a huge difference.